determinant of A, a determinant of B. Determinant of A is going to be 3 times 2 minus -1 times -2, aka 6 minus 2 is 4. This one I have 3. 0. So I'm doing 1 over the determinant for A inverse. No, you're not coming back. Switch the main. Opposite the opposite. Switch the main. Opposite the opposite. Why does this one have an inverse? And this one, all we would say is singular, aka impossible, aka no inverse. What was the difference? And as soon as you have a determinant of 0, if the formula is 1 over determinant times, well, forget it. 1 over 0 doesn't exist. Technically in calculus, we would say it infinitely doesn't exist, or it's an infinite discontinuity, but that doesn't exist. So what's the difference between an inverse existing or not existing? The determinant. Whether the determinant is any constant, negative, positive, rational, irrational, I don't care. Whether the determinant is any constant or whether the determinant is 0. And hence why we said yesterday, determinant is 0 determines, or I should say the determinant determines whether or not the matrix is invertible, aka if the determinant is 0, we have a singular matrix. And really quickly, just in case I didn't emphasize it enough yesterday, determinants only exist of what type of matrices? Not sure if I heard it. Square. Sorry if you guys said that. I heard a few different ones. Determinants only exist of squares. But actually, to be honest, you might not know that because all we looked at yesterday was a 2 by 2. So maybe you wouldn't have realized that. Maybe you wouldn't have realized that. But that's okay, because section 8.4, all about determinants. So we'll be there in a bit. I told people yesterday we're getting there today. We're only spending a little bit more on section 8.3. But 8.3 was inverses, how to undo a matrix in math. Inverses are a huge idea because subtraction undoes addition, multiplication undoes division, ln's undo e's, square roots undo squareds, etc., etc., etc. Just keeps on going after that. So matrices. If we have all this matrix multiplication, that theoretically has application that you guys don't fully see. I get it, like computer programming, that's not exactly the strength of our academic program this year. You guys aren't necessarily in programming classes. Even if you are, I don't know if the high school AP comp sci, from what I remember when we did have a strong program in there, or in that, they weren't really using matrices yet. But in college computer science programs, linear algebra matrices have become a much bigger deal. So I'm not sure if you necessarily will see it now unless you're kind of delving into programming yourself, which is a thing. Jason Johnson, I don't know if you guys, well, Justin even. He was definitely doing a lot of programming in high school apart from the school program. And actually colleges love to see something that you're interested in, something that you're passionate about, that you are independently pursuing apart from what's just naturally offered at school. Some of you are like, the school doesn't offer, what's something random it doesn't offer? We can use comp sci for right now, although they're trying to bring it back next year. What's something else random that we don't have? Lacrosse, there you go. I love lacrosse, and we don't have a lacrosse team. Aren't there community lacrosse clubs? Totally. Now, that's a silly example. But do we necessarily have, what did Adam do this past summer? Do you guys know where he interned? It was like down in LA at some sort of politician's office. Maybe you're super interested in politics, and like, well, you guys don't have any ties to congressmen. You can totally go pursue that as a high schooler now, apart from us. And to be honest, colleges love seeing you pursuing something independent of what you're required to do. And AP classes are a part of that, especially if you have an interest in some sort of like particular emphasis or particular discipline. I want to be a lawyer, let's do all the AP history classes. I want to be an engineer, let's do all the AP STEM classes. I want to be in medicine, let's do all the AP science classes. Like, yeah, okay, you are pursuing something, but it's still within the context or the confines or the specific offerings of your school. They love to see you thinking outside the box. And I'm just saying that because I know that in this classroom we have tons of kids with tons of different desires or interests or goals or passions, and maybe you haven't taken time to think about them. But maybe you have, and you're just like, I can't do anything about it right now anyway. Oh, so not true. Think about it. Think outside the box. Anyway, programming is one of those for right now for us. And I've seen kids who love it and they pursue it and they learn it. Anyway, just encouraging you. Think about what you enjoy or what you might enjoy or what you're interested in. If like, I'm not interested in anything, you start watching TED Talks and be like, what cool stuff is out there? See something piques your interest and go after that. Anyway, tons of different opportunities out there if you guys work for it. You sometimes have to fight for them. Like Kyle doubted his McDonald's job. You fought for it and you got it and he's going to get a paycheck. That might not be what you want to do, but think about what could set you apart or what could be something that you're interested in or that you want to start pursuing now that you feel like you can't, but maybe you can. Alright, anyway, all good things. Determinants can be applied in tons of different ways. We're just applying them to inverses, and the idea of inverses is if you can do a matrix, it's a little awkward, but if you can multiply a matrix, we should be able to, or we need to be able to, or it makes sense in math, we would want to be able to undo it as well. That's the idea of the entire section. So 2 by 2s, we have a nice little formula now. That nice little formula should work out pretty easily, pretty simply. So we're just right here at the end of the section with 2 last ideas. One of these is basically, hey, decimals, does that have to be a calculator thing? Maybe, maybe not. Something you can be thinking of, is there a way to rewrite that to make my life easier? But wait a minute, hold on, this looks so weird because this isn't even just giving me a matrix and asking for an inverse, it's saying solve using an inverse? Like, maybe these 2 pages are tied together a little bit. Check out these directions. Solve using an inverse. I thought inverses were only of square matrices. This one is, what size, guys? The order of matrices, something important to know. 2 by 3. It's a 2-system equation. You could use RREF to solve with like, hey, let's get the 1, 1, 0, 0, and then XY. Wait a minute, 1, 1, 0, 0. Isn't that what inverses find also? So hold on, what if we were to pull out matrix multiplication? Can you guys go backwards? What if we were to factor out matrix multiplication backwards, the XY? And what if we were to take the coefficients? Ooh, do you guys like those decimals or no? All right, so how can we rewrite both of these? Multiply everything by? Yeah, louder, more firm. Multiply by 1? I think I heard a lot of people say 10. I'm going to go for it. 10 because that'll move the decimal place 1, right? Although, what's going to happen to that guy? Yeah. So we're going to have negative 10x plus 14y equals negative 88. Double check I got it all right. I think so. These are negative, negative, positive. Okay. So we can pull that out and get 2, negative 6, negative 10, and 14. If you like decimals, I mean, have fun with that, but a lot of us aren't huge fans, especially for doing mental math. If we have, check it, a coefficient matrix times a variable matrix equaling a constant matrix, that's exactly what this problem is. If you factor away the variables, you have coefficients times variables equal, okay, one way is to augment, and one way is to row reduce. That's what Nathan was doing yesterday, augmenting with the identity matrix, finding inverses, forming, in some senses, the antithesis of the original, forming the the inverse, undoing one to form the other. But the other way is just to do good old-fashioned math. Now, good old-fashioned math says, oh, this is dumb, just divide by A, no big deal, and you'll get your variable. Yeah, that'd be great if matrix division was a thing, which it's not. We tried it yesterday. Didn't work for those of you that weren't here. Matrix division is not a thing. But that's okay, because tangent division wasn't a thing either. We couldn't just divide by can and be done. ln wasn't a division either. Square roots are not a division either. Ooh, that's impossible unless you're imaginary. Anyway, so it's fine. No big deal. In math, if division isn't the thing, just think outside the box and say, I just need whoever his inverse is. We have an inverse of a matrix. We figure out how to find it in this entire section. So if we have an inverse, it's not division, it's just its inverse. No big deal. But what we do on one side with a matrix, we have to do in the same location on the other side. Remember, order matters. So how do we undo with an inverse? We just multiply both sides by it. In the order that it will take out, well, technically, it will make the identity. And the identity times anything is its sum. So all I really need to do is multiply this guy by the determinant, well, 1 over the determinant, of that guy times, switch the main and opposite, the opposite. What's the determinant? We have 28 minus 60. 28 minus 60 is going to be negative, oh dear, and we have to reduce 14 over 30. Does that keep going? 7 over 50? Did someone beat me? Was it 7 over 50? The determinant? Oh wait, I'm subtracting. I'm silly. I was dividing. I have no idea why I was dividing. Main minus opposite. Lo siento. 28 minus 60 is negative 32. I think you guys were saying it. I just had a fraction in my head for some reason. And then we just multiply the whole shebang. We have to multiply the whole shebang. That's true, but if you're in a calculator, this is so much easier. And once again, you're like, I would just do RREF. That's fine. That's one way. I would just do elimination. Okay, that's another one. You're a human. You can be creative. But if you're trying to use your calculator, you could have just put in matrix A and just done A with the little -1 button that you saw yesterday. People who were not here, there's a -1 button that you hit to get to the matrix. You can also use it to a matrix to get the inverse. And you could have just multiplied it by that 24, -88 answer as well. So you could be plugging into the formula, or you could just be going for it as far as using your calculator as well. So really quickly, just for those of you mostly that were gone yesterday, using that inverse feature, because it could be helpful. We can get there. You could have taken this original guy. Remember that second inverse, that second, it's normally a reciprocal button for numbers, but for matrices, we saw yesterday, it is the inverse. So we can go ahead and edit to make our matrix A, for instance, which is this first guy, our coefficient matrix. And then we could have done that matrix A. We can use the negative, I am not in the right place. That matrix A with that little inverse button. He'll totally solve for the inverse for me, which is cool on the calculator portion of the test for sure, because you wouldn't have to be thinking or even doing any by hand work. And then we would just want to multiply it by that matrix B if we were following the directions of like, oh, hey, this works too. And it should be the exact same thing as if we were to augment. Let's see, what do we have, a 2 by 1? And do RREF. Six -2, which yes would have also been gotten by elimination or substitution or RREF if you put the whole thing together. That's the times, right? Does that look weird to you? No. We end up with 6 -2 as our xy, which would have also occurred if we had gone ahead and done matrix multiplication. It just would have been tedious. 14 times 24 minus 6 times -88, 10 times 24 minus 2 times -88, all with our -1 over 32. It would have just taken time. But we should have gotten there eventually. It would have been a while. Okay, so anyway, this one might show up in homework just a little bit. It's just a kind of snazzy application in the sense of using technology in a way. It might be faster for a program in order to solve a system to do an inverse times the constant rather than having to think through the entire RREF if this was like a 10 by 10. And in computer algorithms, it's nice to have something done in fewer steps because then it makes it more efficient. It can run faster. The fewer steps accomplishing the same goal, the better. All right, so that ends us at, I think, there we go, section 8.3 being done. For those of you guys that were in class yesterday, I was like, hey, start homework because I'm going to totally offer to be available to help you through any places that you've gotten stuck. So I'm going to open up the book and I'm going to be prepared if anyone has anything that they want to go over in section 8.3. But as I prepare to do that, you guys are opening up new section, new side, but really we're starting right where we left off in that, like, oh, so these determinant guys, they're important, huh? Kind of like dot products. These determinant guys, they're important. And once again, I'm not necessarily apologizing for Precalc. I warned you guys at the beginning of the year. It is what it is. It's kind of not a random, eclectic collection, but it feels like it sometimes of like all these different little baby pieces of future maths that might show up. We've done future function analysis with like our parent functions and our even trigonometric, future physics with our trigonometric work and our vector work. Future, right now we're in kind of future computer programming, the future linear algebra with matrices. Chapter 9, we get to go into future probability, statistics, etc. Chapter 10, it's getting a little bit more specific to future geometry, abstract geometry, non-Euclidean geometry. I'm barely touching on it, but with conic sections in way future calculus, but deeper function analysis. Chapter 11 would be future physics, again with 3 dimensions instead of just 2 dimensions, but we're skipping that one. And then chapter 12 is, okay, no, but seriously, you're going to calculus, hopefully, or at least this is where this class is supposed to lead. So anyway, I'm not apologizing for it, just kind of reminding you, it might feel weird, it might feel random, we're jumping around a lot this year, but it is just kind of for the future, giving you somewhat of a foundation in all these different pieces. All right, my kiddos that were working on homework last night, is there anything you want me to take a picture of and get ready to go? Or get ready to talk about any place you got stuck? Oh, it can be no. I was just being available. Anything from section 8.3 you want me to look at or just give a tip or a hint? 71. 71? Cool. Thanks, Lucas. Anything else besides 71? Okay. So the rest of you guys are tackling this tonight, trying this tonight, but it seems like it's not that out there in the sense of I know there's at least quite a few of you were kind of working on it yesterday. I see a few of you working on it today, and it seems like this is the only place people are stuck so far. So maybe not too bad as long as you have the notes and the formulas ready to go. So as you guys are taking notes, let me go ahead and get this pasted in. It's a word problem, which some of you are like, huh, thanks, Lucas. Meaning, you wouldn't have liked this tonight. Let me also get my calculator kind of set up and ready to go too. Because on the test, I can tell you right now, I'm not going to be asking you to do matrix work with word problems without your calculator. I'm not saying I necessarily will. I don't think there are that many word problems on this test. It's mostly just skills based. Skills by hand and then skills with your calculator. Working with the matrices, but still good practice for you guys to be able to see kind of how they're applied. This one's actually somewhat practical in my life. And Mrs. Rodley's life in the office too. She does studying flowers. One of my friend's moms does studying flowers on the side. And she goes to the LA Flower Mart and has a notebook out.
I'm doing a note.
She does a lot of this work in her head, but it's kind of trial and error, and man, it's a messy process. Mrs. Rhonda is probably a little bit more professional now. She's been doing it.
Can you handle it?
A little bit longer, but this one's saying, hey, there's a lot that goes into trying to figure out what's going on for a wedding reception. Actually, Ron, junior student council is supposed to be thinking through some of this for their flowers for prom, but that's a Mrs. Rainieri thing to figure out. A florist is creating 10 centerpieces for tables at a wedding reception. Roses cost $2.50 each, lilies $4 each, irises $2 each. The customer has a budget of $300 allocated for the centerpieces alone. On each centerpiece to contain 12 flowers. So right now I see roses, sure why not, lilies, sure why not, and irises, sure why not. 12 of them total. Cool. I see money, only spending $300, right? Separating these characteristics. And then those roses are $2.50. Those lilies are $4. Those irises are $2. Yes, budgeting, lily-wise thing to do, not just be like, yes, spend whatever you want. That's just twice as many roses as the number of lilies and irises combined. Twice as many roses. Twice as many roses. Wrong way. Roses, which is X, is twice as many. My mind is having to think in variables, like being like, okay, X are roses, Y's are irises, Z's are lilies. Making or taking each of these statements and trying to summarize them down. You can take words and try to simplify as much as possible. It can be helpful in so many ways. Not just like translating whole paragraphs of information to mathematical statements, but also in things like reading comprehension sections of the SAT. Huge body of text. How do I summarize? How do I break it down? I'm not saying you have to go to variables and mathematical equations, but being able to kind of pick out the main pieces of information. Helpful. Okay, roses are twice as many irises and lilies. Got it. Okay, so with this whole shebang, it's almost written like a nice system. What's the one thing I should rearrange? Yeah, this one, right? I can just subtract the 2y, subtract the 2z, and I can have this in a much nicer order as far as putting into a matrix. Now that's ready to go into a matrix. But hold on, what are we supposed to be doing? My system of equations, okay, check, I have that. Write a matrix equation that corresponds to your system. I can totally do that. They're just making sure I know how to. If you guys don't mind, I'm going to go ahead and do that in my calculator instead. In that, I have to probably put it in there anyway, because this is saying solve the system using an inverse matrix, finding the number of flowers. So, once again, I could augment my coefficient with my ladder n, section 8.1, and I could use RREF, and it would solve my system. That would be one way. But once again, they're just trying to have me see another application of inverses. And this is truly like the most mathematical way of solving a system, because you are literally undoing in one fell swoop with an inverse matrix. You're literally undoing all of those coefficients from all of those variables all at once, which is kind of a crazy idea. If you think about all the math that would be involved with our, what was it, section 7.3 REF, if you were solving this one by hand. But let's just go throw this guy in really quickly, and I would edit and make it a 3 by 3 for my coefficients. The other guy would need to be a 3 by 1 to get my constants in there, and I would just throw in my 2. Yeah.
So the 12 wouldn't be 120, because there's 10 centerpieces.
Ooh, nicely done. Thanks, I just went too fast, didn't I? I used to bite my butt and read comprehension too. I summarized a little too fast. Each centerpiece, I didn't even read that. 12 flowers each. Thanks, Ben. Which means, you guys might not have heard him. He was like, hey, wasn't that 12 per each centerpiece, aka 10 times 12 is 120? Good catch. So I have my 2.5, my 4, my 2, my 1, my 1, my 1, my 1, my -2, and one more -2. Double checking that you put your matrix in right, because guys, one little like a negative changing could mess the entire shabam up, and that would be a bummer. But now I can go edit, make it a 3 by 1 to get my other guy. I would have my 300, my 120, and my 0. And all I have to do is use that snazzy inverse button and say, okay, I'm going to undo that entire mathematical system in one fail inverse swoop. So inverse A times all of this would knock him out. I would have my x, y, z, and then I could go ahead and multiply by b. There we go. I want 80 roses, 10. I don't remember which is which. Irises? 30 lilies? I think I just did that wrong. So I want 80, 10. Roses, lilies, and irises. What we're doing there again is this is our matrix A with all of our coefficients. We multiplied by the inverse, which would knock that out and end up getting there. But when I do it there, I have to also do it over here. And if you guys accidentally do it the wrong order, your calculator's going to be like, what are you talking about? I can't do that. It's illegal. So hence why we have to do it in that original A inverse times B. We could not have switched these two or it would have totally failed on us because the orders wouldn't match. But Lucas, that good? Here's paragraph text broken down into one little itty bitty matrix multiplication. Well, using an inverse button on my calculator, which I'm very thankful for. Okay, so with that, let's go ahead and bust into section 8.4 that you guys have all set up and ready to go. And to be honest, you're totally ready for it because you already know, hopefully, or at least you see AB minus BC is how we got that determinant. You guys have already seen me use the DET notation. The calculator used it too, although, I mean, probably threw in, oh, I didn't use it on this one. I think the calculator, you're going to ultimately end up having parentheses and brackets just because over math, DET, maybe I haven't shown you that, I just alluded to it yesterday. I mean, it's going to have parentheses because it wants the determinant, but then the bracket is for the matrix, but really, whatever, like just by hand, determinant of A, that's fine. But the other way that's going to get confusing unless you get it down is absolute value, which they could put around the name, or they could put around the entire matrix. Ooh, sorry. A, B, C. Absolute value is around a complex number. It's the magnitude. I need to take the Pythagorean theorem of my real and imaginary components. Absolute value of a matrix is its determinant. Don't say absolute value. Please don't say absolute value. I'm just trying to connect the notation for you. It's not the actual absolute value. If I see these guys, I'm going to say determinant. I'm going to say determinant if I know in context it's a matrix. Okay? But after that, you guys know it's main minus opposite. Remember from yesterday? 1 year's honors pre-cal a few years ago. They were like, main opposite. Whatever. I don't know. I'm not sure if it's really that much faster. But if I accidentally say main opposite, just know what I'm talking about. Main minus opposite. But main, we're just multiplying kind of like a dot product. I mean, kind of, not at all. But we're just doing multiplication, taking that entire row, multiplying 4. Minus opposite, just be careful of those signs. If you try to go mental math too fast, you might just mess up your signs a bit. Is this guy singular or non-singular? There you go. You have to think about it because it's weird. It's awkward, right? Will this work? Yes, for an inverse, but that's actually non-singular, right? Singular is when it doesn't work. That's when, just think it's like on its own. It's kind of sad, but it's on its own. It's singular. It doesn't have an inverse. But yeah, good job. You got there. Non-singular. But how about this one? Singular. AKA no inverse. AKA if you try to multiply him by someone, he can't be undone. Which is also interesting because then if he shows up in a system of equations and he can't be undone, then he would be an impossible system. Oh, I still mixed it up. Thanks. I started to do it AD, and then I went to A. I was supposed to be going to AD. And obviously, my brain didn't quite get there, or at least my hand didn't. Communication is key. There's a life lesson in there somewhere. Sorry, my pastor, Pastor Brad, he's talking a lot about the body of Christ, and so I'm like, anyway, drawing all these illusions in my head. Come back. Telling myself, you guys, some of you need to come back too. I might have lost you a while ago. Main, whoop. Good friend. Good job, Zway. Main minus opposite. Hey, how are we doing with fraction multiplication? You guys get 3? Some of you need to be thinking about 2 over 1 to make it easier on your brain as far as the mental math. I know it's weird, but in Precalc, I'm trying to get you more familiar with fractions, with factoring, with all sorts of basic stuff that you haven't mastered yet. The 3 halves times 2, same thing as the 2's reduced and I have a 3. Some of you, that's so natural, and some of you, oh, it's not. It's okay. Do whatever you need to for your brain to make sense of it. Is that singular or non-singular? Yeah, because remember, it doesn't matter if it's a negative or a positive, just whether or not 0. I can do 1 over a negative for an inverse, no big deal. So, just reminding you of 8-3. That is what your homework's on tonight. But what if we don't have 2 by 2s? Those are easy. Main minus opposite. As long as you keep your sign straight, you're good. If it's a 0, I mean, that's still the determinant. We just know that the inverse wouldn't work. But over here, what if we have a 1 by 1? Life is good. It's just the element. It's just the entry. That's it. You're done. But the sadder question is, what if we have anything besides a 1 by 1 or a 2 by 2? And that's where it gets to be a bit interesting. Now, the nice thing is, okay, the very beginning of homework, you're not going to have a choice. Sorry, it's been taken away from you. The book is going to say you have to use this row, or you have to use this column, or you have to use both. Why? They're proving a point number 1, but they're also trying to tell you what your brain would naturally think is easiest might not always be so. So kind of exposing you to choosing something other than you would naturally once you learn this process. But then, after you are forced a couple times to do it particular ways, then you're kind of given the freedom of choose whatever row, whatever column you want. Now, in all of this that I've been saying, I've been indicating that 1 row or 1 column needs to be used in the finding of the determinant. And I've been indicating that eventually you get to choose which column or which row seems best. But I've also been indicating that maybe what seems best is not necessarily the easiest. Doesn't mean it's wrong. Easiest is not always the way to go. But I'm going to show you how to do it, and then we're going to look at the formula. If I show you the formula first, you're just going to hate it automatically. Let me show you how to do it. And then let me show you the formula that's actually pretty complicated to make, because once again, I just said you can use any row, any column, so how do you put that in a formula? Okay. Can you just follow the pattern? I've circled the O, I've crossed, I've crossed. I've circled the 2, I've crossed, I've crossed. What would I do next? Circle the 1, this one, right? And? Okay. So, A11, I've eliminated row 1, column 1. A12, I've eliminated row 1, column 2. A13, I've eliminated row 1, column 3. Whatever one I'm looking at, I'm eliminating its corresponding row and column. And check it. I'm going to take that entry, I'm going to multiply it by the determinant, see the absolute value or the bar, of whatever's left. Then I'm going to, now here's where it gets a little weird, I'm going to subtract whatever comes next, whatever next entry, whether I'm going across or going down. I'm going to go ahead and take where I'm going, the direction I'm headed. Take that entry and multiply by whatever's left after I eliminate the determinant of that matrix. Then I'm going to, now it's going to even look weirder, add, wait, you subtracted, now you're adding what? Whatever the next entry is, times its, or the determinant of what's remaining for it. The nice thing is 0 times anything, I like those because they just go away. This one, well, I'm going to have a 2 times. Now I need main minus opposite, so 3 minus 8. I'll get back to it in a second. Plus 1 times main minus opposite, 0 minus negative 4. Do whatever you need to, write however much you need to get it right. And now all of a sudden I have a negative 5 times a negative 2, which is a positive 10, and I have a 1 times a 4, which is a 4. I showed you guys where the DET button is in your calculator. Can you double check that I'm right and make sure that you know how to find the determinant of the mean? Did you see where I found the DET a second ago? There are going to be a few different times. This will be really helpful on your test to be able to do a determinant with your calculator in the calculator portion. I'm right? Cool. Did you guys hear me a second ago say that you could choose any row, any column? Can you try to do the exact same thing but with a different row or a different column? Ready, set, go. Your goal is to get 14. Choose any row, any column. Don't go diagonal, any horizontal row, any vertical column. Try to do the exact same thing. See if you can repeat the process. And as you guys choose one, you can choose one for me. And I'll still try to beat you. Which one should I do? Bottom. Wait, that's not a row or column. Like this one or this one? Giving me an easy one with a 0? Oh, no. Do you want to give me row 2? Depending on which one you chose, you might have had to make a change that you didn't even realize was a thing. I had to make a change because you guys chose for me row 2. If you chose row 2 or column 2, something changed. What's different between how I set that up and how I set this up? Signs. He started positive, then went negative, then was positive again. But what did I do? There's some pattern working behind the scenes that you might not have realized, beyond or above and beyond the choosing of the entry and the finding of the determinant. So check it. When I was bringing down the 0, I put a positive. When I was bringing down the second entry, I put a negative. When I was bringing down the 1, I brought a positive. But when I brought down the 3, when I brought down the -1, when I brought down the 2, if you were bringing down the 4, there is a pattern. There is a pattern behind what I'm putting in front of each entry. And guys, it's always going to start with a positive, and it's always going to alternate across and down. And so depending on, you need to check which row you did or which column you did. Did you put the correct signs for whichever ones you were using? All of this is summarized in a big old huge formula. Oh, that's not it. A big old huge formula. Here we go. How to find the determinant of a square matrix. Where these are entries, A11, A12, A1 to the n, but it can be any size, hence the ... and it can be any row. And then there are these guys called cofactors that are talking about this alternating sign pattern. And that alternating sign pattern, you see it? I know it's tiny. Plus, minus, plus, plus, minus, plus, minus, plus, minus, plus, minus, plus. Like, it just keeps on going. You just always start in this corner with a positive and alternate. And there's some special terms for, like, hey, this little dude that you're stealing, he's called a minor. Putting the correct sign on it, it's called a cofactor. But we're going to talk more about that tomorrow. This is basically how you do it. Bye, guys. We started determining. Excellent job. We finished inverses. Bring 3 questions in case you get stuck anywhere else. But we should be right now. I think I'm good. Bye, guys. Wonder, what are you passionate about?
Yeah, I'm just going to read on the side. I'll copy it. I'm just so tired of getting sick on every day.
You're tired of what?
Getting